Flight tracking services and websites have brought exciting and valuable changes to the aviation sector. These provide real-time and historical access to flight information, including aircraft details, routes, position, speed, altitude, and heading. Today, let's look at how flight tracking sites work. Radar and onboard transponders are the primary method to make aircraft visible to controllers. However, this data cannot generally be accessed by others. Automatic Dependent Surveillance Broadcast, or ADS-B, has changed this, with the data broadcast by aircraft using unencrypted signals via 1090 MHz. Indeed, anyone with a receiver and the proper antenna can pick up the data. This is a relatively new method, but it's already well on its way to mainstream use. Aircraft determine their position by communicating with satellites, then broadcast this to air traffic control to enable tracking. ADS-B will also transmit aircraft identification information, altitude, and speed. It can also receive information such as weather updates, airspace information, or other ADS-B aircraft reports. Radar tracking remains the long-standing global standard method of aircraft tracking, but ADS-B is well on the way to replacing it. In the US and Europe, all commercial aircraft are now required to install ADS-B technology. Upgrade projects for ATC are underway in both regions, the Next Generation Air Transportation System in the US and the Single European Sky ATM Research, or SESAR, project. ADS-B will ultimately change how ATC and aircraft tracking works, unlocking coverage in areas where it was previously limited. It'll allow for more efficient aircraft routing and spacing too. This technology also makes aircraft data available to sources other than ATC, and this is how flight tracking websites obtain data. Indeed, most commercial aircraft are now broadcasting ADS-B data. In fact, FlightRadar24.com estimates that 70% of all commercial traffic now has an ADS-B transponder, and this will continue to increase. But this data needs to be collected. This is done mostly using volunteers to host and operate ADS-B receivers and feed the data to tracking websites. These are mostly aviation enthusiasts who agree to install a receiver, aerial, and connect it to the internet. This then feeds data from that area to the service provider. For full global coverage, a huge network is needed, as each receiver will cover about 250 to 450 kilometers or 150 to 250 miles in all directions. FlightRadar24.com claims to have a network of over 20,000 such receivers in place currently. The website claims that it can now cover 100% of airspace above cruising altitude in Europe and the US, and this is increasing in plenty of other regions. Security and legal implications are of course a concern, and thus data from certain aircraft or operators are blocked from display. While ADS-B provides the primary source of data for flight tracking, multilateration, or MLAT, is a technique that uses the data from several receivers to calculate the position of aircraft without ADS-B transponders. By measuring time differences of standard transponder signal receipts between multiple receivers, the aircraft position can be tracked. FlightRadar24.com covers most of Europe and US airspace between 3,000 feet and 10,000 feet with MLAT. Traditional radar sources can also be used in some areas. In fact, FlightRadar24.com currently sources standard radar data for commercial traffic in North America and over parts of the Atlantic and the Pacific Oceans. Do you frequent flight tracking websites? Which site do you prefer? Let us know more in the comments. In addition to our daily YouTube videos, Simple Flying publishes over 150 articles every week. If you're looking for the latest aviation news and insights, visit simpleflying.com.